Fine, let's start. Number 10. The world where it rains iron. Picture a planet about the size of Jupiter, only bigger and angrier, hanging in the dark. There's no sun in its sky. No dawn, no dusk, no warm yellow star to tilt toward. Just black in every direction, forever. And in its clouds, it's raining iron. Not water, not even acid. Droplets of hot, molten metal, drifting down through layers of glowing dust. This is a real place. We have its picture. Astronomers call it PSO J318, and it sits about 80 light years from here, in the direction of the constellation Capricornus. A team led from the University of Hawaii found it in 2013 in survey images taken back in 2010. And the moment they worked out what they were looking at, they realized they had something strange on their hands. Because this thing has roughly 6 to 8 times the mass of Jupiter, which puts it square in planet territory. But it isn't orbiting anything. It's just out there, alone, drifting through the galaxy with no star to call home. It's young, as these things go, around 23 million years old, which sounds ancient until you remember our solar system is over 4.5 billion. So it's still warm from its own birth, still glowing faintly with leftover heat. And that's the only reason we can see it at all. In visible light, it's about 100 billion times fainter than Venus. 100 billion. If you tried to spot it with your eyes, you'd have a better chance of seeing a candle on the moon. When researchers studied its light more closely, they found weather. Layers of cloud made of hot dust and that molten iron, churning, shifting, brightening, and dimming as the planet turned. Storms moving across a world that nobody is keeping warm. And here's the thing that stays with me. We tend to think of planets as belonging to a star. Earth belongs to the sun. The sun is our anchor, our clock, the thing that makes a year a year. This world has none of that. It rains iron in the dark, and it has been doing so for 23 million years, and it will keep doing it long after every one of us is gone, with no one to see it. And it is not alone in being alone. Number 9. The one that proved they were out there. For a long time, rogue planets were mostly a story we told ourselves. The math said they should exist. Planets get flung out of young solar systems all the time, kicked loose by the gravity of bigger siblings, sent tumbling into the dark. So in theory, the galaxy should be littered with them. But theory is one thing. Pointing a telescope at one and saying, there, that one, that's a planet with no star. That's something else entirely. In 2012, a group of astronomers announced a candidate that got everyone's attention. It carries the catalog name CFB-DSIR 2149, and it was found by a survey hunting for the coldest, faintest objects in the sky, then confirmed with data from a NASA infrared telescope. At the time, they thought it was relatively close and relatively light. They tied it to a young group of stars all drifting together through space. And if it really belonged to that group, it would be young, which would make it small, somewhere around 4 to 7 times the mass of Jupiter. A free-floating planet, practically in the neighborhood. It felt like a milestone. One of the first times we could look at a specific object and say, this might be a planet all by itself with no sun. But here's the twist, and it's a very human one. The closer we looked, the less sure we became. A few years later, a fresh measurement of its distance pushed it much farther away than first thought, out to something like 180 light years. And that one number unraveled a lot of the story. If it's farther, the link to that young group of stars gets shaky. And if that link breaks, then we don't actually know how old it is. It might be a young rogue planet, just a couple to 13 times Jupiter's mass. Or it might be a much older, heavier object, a failed star quietly cooling for billions of years. So, one of the first rogue planets we ever thought we'd identified is still, to this day, an argument. We're not certain what it is. And I love that in a way. It's a reminder that this whole field is brand new. We are standing at the very edge of what we can detect, squinting at faint smudges of infrared light, trying to tell the difference between a planet and a failed star from across nearly 200 light years. Sometimes we get it right. Sometimes we just have to admit we don't know yet. Number 8, the frozen neighbor. Everything so far has been comfortably far away. 80 light years, 180. Numbers big enough to feel safe. So let me bring this closer, uncomfortably close. There is a sunless world drifting about 7 1/3 light years from Earth. To put that in perspective, the nearest star to the Sun, Proxima Centauri, is just over 4 light years away. This thing is one of the closest objects to us in the entire galaxy. It is practically next door in cosmic terms, and we did not even know it existed until 2014. It's called WISE 0855, named for the infrared telescope that caught it. An astronomer named Kevin Luhman spotted it by noticing something faint creeping across the sky from one image to the next. And when they measured its temperature, they got a shock. This world is cold. Genuinely, deeply cold. Somewhere around -13 to -48 degrees Celsius. That makes it the coldest object of its kind ever found drifting in interstellar space. Colder than anywhere on the surface of the Earth. Colder than the dark side of most things you can imagine. It's roughly 5 times the mass of Jupiter. So, again, planet scale, or close to it. And then came the detail that turned it from a curiosity into something genuinely beautiful. When astronomers studied its infrared light, they found evidence of clouds made of water ice, drifting in its atmosphere. The first water clouds ever detected on a world outside our own solar system. Sit with that for a second. We have a neighbor, a frozen, starless planet, almost close enough to feel like part of the family, with clouds of water ice and its own quiet weather, and we walked right past it for the entire history of astronomy until a little over a decade ago. It makes you wonder what else is out there in the dark, just past the edge of the porch light, not far away in some distant arm of the galaxy. Right here, close enough that, on the scale of the cosmos, we could practically reach out and touch it. And the unsettling answer is, we genuinely don't know. There could be more of these, colder, darker, even closer. We only found this one because we got lucky and built the right telescope. The dark is not empty. It's just patient. Number 7, the world that glows on its own. Here on Earth, the northern lights are one of the most beautiful things our planet does, and we know exactly where they come from. The sun throws a constant stream of charged particles at us, the solar wind. Earth's magnetic field catches those particles and funnels them down toward the poles, where they crash into the upper atmosphere and make it glow green and red and violet. No sun, no solar wind. No solar wind, no auroras. That's the rule. About 20 light years away, there's a rogue planet that breaks it. Its name is a mouthful, so let's just call it the Glowing Wanderer. It's around 12 to 13 times the mass of Jupiter, fairly young at about 200 million years old, and it is absolutely on its own. No star anywhere near it. In 2018, a team led by an astronomer named Melody Cow pointed a powerful radio telescope at it, an array of dishes in New Mexico, and made history. It was the first time anyone had ever measured the magnetic field of a planetary mass object outside our solar system. And what a magnetic field it is. More than 200 times stronger than Jupiter's. Roughly 4 million times stronger than Earth's. This is a world wrapped in an absolutely monstrous magnetic cage. And inside that cage, the radio signals showed something astonishing. Auroras. Powerful ones. Light show after light show. Rippling across a planet that has no sun to power them. So here's the question that hangs in the air. If there's no star, no solar wind, then what is lighting up the sky? What's feeding those auroras? And the honest answer is, we're not completely sure. Maybe there's a moon we can't see, spitting out material the way one of Jupiter's moons does. Maybe it's something happening deep in the planet's own churning interior. The point is, this world found a way to make light in total darkness, all by itself, and we are still working out the trick. I find that almost defiant. A planet cast out into the black, with no sun, no warmth, no anchor. And what does it do? It lights up anyway. Number 6. The planet that eats like a star. We keep using these two words like they're completely different things. Planet, star. One is a world, the other is a sun. Easy. But the deeper you go into the dark, the more that line starts to smear, until you find objects that simply refuse to sit cleanly on either side. Meet a free-floating object called OTS-44. It lives in a young star-forming region. It's only about 2 million years old, a newborn by cosmic standards, and it weighs in at roughly 12 times the mass of Jupiter. By mass alone, that's a planet, or very nearly one. But it does something planets aren't supposed to do. It feeds. Around it, astronomers found a disk, a swirling ring of gas and dust with about 10 times the mass of the Earth in raw material. And this object is actively pulling that material in, falling onto itself, growing. The measured rate is staggering, something like 500 billion kilograms of matter every single second, pouring down onto a planet-sized world. This was the first time we'd ever caught a free-floating planetary mass object actively eating like this. And here's why that matters. Feeding from a disk is what baby stars do. That's the star playbook. A cloud of gas collapses, spins up, forms a disk, and the central object gulps it down and grows. Finding a 12 Jupiter mass object doing the exact same thing tells us that the process that builds stars doesn't stop at stars. It keeps going, down and down, into the planetary range. When the researchers, led by an astronomer named Vicky Jorgens, ran the numbers, they found something elegant. The ratio of the disk's mass to the central object's mass was almost the same, whether you looked at a big star or this tiny planet thing. About 1%, all the way down the scale. As if nature is using the same recipe at every size, just shrinking it. So is it a planet? Is it a tiny failed star? Honestly, that might be the wrong question. The truth this object is whispering is that there may not be a hard wall between the two at all. Just a smooth gradient, from giant suns at the top, all the way down to lonely worlds like the ones in this video. And somewhere in that gradient, the word planet quietly becomes the word star, and nobody can tell you the exact moment it happens. Number 5. A solar system around nothing. This is the one that genuinely bent my brain when I first read about it. So far, we've talked about lonely planets, single worlds, drifting by themselves. But back in 2004, an astronomer named Kevin Luhman, the same person behind a few of these discoveries, found something stranger. A free-floating planetary mass object out in a region of sky toward the southern constellation Chamaeleon, roughly 500 light-years away. On its own, no star. So far, familiar. Except this one wasn't bare. It was surrounded by a disk, a flattened, swirling ring of gas and dust, the exact kind of structure we see around young stars right before planets form inside it. At the time, it was the smallest such disk ever found around a free-floating object. The central world is somewhere around 8 times the mass of Jupiter, firmly in planet territory. Now, follow the logic with me, because this is where it gets dizzying. Disks like that are where moons and planets are born. The dust clumps together, sticks, grows into pebbles, then boulders, then worlds. So this object has, swirling around it, the raw ingredients to build its own little family, its own moons. maybe even its own tiny planets. Which means you could end up with a complete miniature solar system. Worlds orbiting a world. A whole system with structure and hierarchy and motion. And at the very center of it all, where you'd expect to find a warm, shining sun, nothing. Just a dark, drifting planet that belongs to no star. Think about what that would actually look like from the surface of one of those hypothetical moons. You'd have a parent world hanging in your sky, huge and dim. You might have sibling moons sliding past. You'd have all the rhythm and company of a solar system. And beyond it, in every direction, total blackness. No sun rising, no sun setting. Your entire little family, adrift together in the void, anchored to nothing. We don't know for sure that moons ever actually formed there. The disk might not have finished the job, but the materials were right there, doing exactly what they do around young stars. A solar system trying to assemble itself around an empty center. Loneliness, it turns out, comes in layers. Number 4, the smallest ghost. Everything we've talked about so far has been big. Giant planets, several times the mass of Jupiter, glowing with their own leftover heat. And that's not a coincidence. Big, warm worlds are the easy ones to find. They give off light. They show up. But the math says most rogue planets shouldn't be giants at all. They should be small, rocky, Earth-sized, Mars-sized, the kind of world that gets flung out of a young solar system because it was little enough to bully. And a small, cold, rocky planet with no star gives off essentially nothing. It's invisible. So how on earth do you find one? You wait for it to bend the light of a star behind it. There's a trick astronomers use called microlensing. When a massive object passes directly in front of a distant star, its gravity acts like a lens. It bends and focuses the starlight, and for a brief window, that background star appears to brighten, then fade. The bigger the object, the longer the brightening lasts. A star passing in front might cause a flicker lasting weeks. A planet, much less. In 2016, a survey caught a brightening that lasted about 41 minutes. 41 minutes. That was, and remains, the shortest event of its kind ever recorded. And when researchers worked through the physics, they concluded the most likely cause was a rogue planet, somewhere in the range of Mars to Earth in mass. A small, rocky, terrestrial world with no star anywhere near it, betrayed for less than an hour by the way it bent the light of a star sitting far behind it. And then it was gone. That's the part that haunts me. Microlensing doesn't repeat. The alignment that revealed this world will essentially never happen again. We got one look, 41 minutes. A rocky planet, roughly the size of our own, wandering the galaxy in total darkness, and we will almost certainly never see it again. It announced itself once, by accident, and vanished back into the black. For every giant we can photograph, there are countless little ghosts like this one. Worlds the size of home that we can only catch in the act of bending starlight, and only if we happen to be looking at exactly the right pinpoint of sky at exactly the right minute. Which raises a very large question. If the small ones are this hard to see, just how many of them are out there? Hold that thought. We're getting there. Number 3. The planets that travel in pairs. In late 2023, the James Webb Space Telescope pointed at the Orion Nebula, one of the most famous and most studied star-forming clouds in the sky, a place we have stared at for generations. And it found something nobody was ready for. Pairs of planets, drifting together, with no star, about 40 of them. 40 pairs of Jupiter-mass objects floating through the nebula, each pair gently orbiting each other, and not one of them attached to a sun. Astronomers gave them a name that is honestly kind of adorable for something so profound. Jumbos. Jupiter mass binary objects. Their masses range from under 1 Jupiter up to around 30, and they come two at a time, locked in a slow waltz around their shared center, out in the open dark. And here's why this set the entire field on fire. We have two main stories for how things like this are supposed to form. Story 1 is the star story. A clump of gas collapses under its own gravity and lights up. But the standard version of that story really doesn't like making things this small, and it certainly doesn't explain why they'd come in matched pairs. Story 2 is the planet story. A planet forms around a star and then gets kicked out into space. But the kick that ejects a planet is violent. It is very hard to fling two planets out together and have them stay gently bound to each other as a pair. The gravitational shove that frees them should rip them apart. So neither story works cleanly. We have 40 examples of something the rulebook says should be rare to impossible, sitting right there in one of the most observed patches of sky in astronomy. Now, I'll be straight with you, because the channel is built on honesty. Not everyone is convinced. Some astronomers have argued that a chunk of these might be background stars, reddened and disguised, masquerading as planet pairs. The debate is genuinely live. People are still fighting about it, taking new measurements, even catching faint radio signals from at least one of them, trying to figure out what these things actually are. But if they're real, and the case is getting stronger, then they're telling us something humbling. The galaxy is doing things we have no theory for, right under our noses. In a nebula we thought we understood. 40 pairs of giant worlds, dancing with each other in the dark, having formed in a way we genuinely cannot explain. The universe doesn't owe us a tidy rulebook, and every so often it makes sure we remember that. Number 2. Life in eternal night. Let me ask you the question that every one of these worlds has been quietly building toward. A planet with no sun, no light, no warmth from above, frozen and adrift. Surely that's the deadest place imaginable. Surely nothing could ever live there. And yet, some very serious scientists think the opposite might be true. Back in 1998, a physicist named David Stevenson published an idea that sounds like science fiction and isn't. He pointed out that a rogue planet could hold onto a thick atmosphere of hydrogen left over from its birth. And hydrogen, under pressure, does something clever. It lets visible light through, but it traps heat trying to escape as infrared. It acts like a blanket. A really, really good blanket. So imagine an Earth-sized rogue planet wrapped in a deep hydrogen atmosphere. It has no sun, true, but it doesn't need one because it has another heat source. Itself. Deep in its core, radioactive elements are slowly decaying, releasing heat exactly the way they do inside our own Earth. Normally, that heat just leaks away into space. But under a thick enough hydrogen blanket, it gets trapped. And Stevenson's math showed that the trapped warmth could be enough to keep the surface above the freezing point of water, liquid water, on a world with no star. And it gets better. Other researchers showed you don't even need the surface to be warm. A later proposal, nicknamed the Steppenwolf model, described a rogue planet with an ocean kept liquid underneath a protective shell of ice, warmed entirely from below by the planet's own internal heat. We actually have a version of this in our own solar system. Moons like Europa and Enceladus hide oceans under ice, warmed not by the distant sun, but by internal forces. A rogue planet could do the same thing, just out in interstellar space, all alone. And just this year, in 2026, new modeling suggested that the moons of rogue planets could keep liquid water oceans for a staggering length of time, up to around 4.3 billion years. That is roughly the entire age of the Earth. Long enough in principle for life to begin and evolve and become something. Here on our own planet, we've found whole ecosystems clustered around deep-sea hydrothermal vents, in total darkness, miles down, that never see a single ray of sunlight. They run entirely on the Earth's internal heat and chemistry. Life, it turns out, does not strictly need a sun. It needs energy, and liquid water, and time. A rogue planet might have all three. So here is the thought that I cannot shake. We have always pictured life clinging to the warm zone around a star, the narrow, lucky band where it's not too hot and not too cold. But if Stevenson is right, the most common home for life in the entire galaxy might not be a sunlit world at all. It might be a dark one, drifting, starless, wrapped in ice and hydrogen, warmed from within, hiding an ocean that no light has ever touched. The galaxy might be full of life, just not where we've been looking. Number 1, the galaxy is mostly rogue. We've spent this whole journey looking at rogue worlds one at a time. The Iron Rain planet, the frozen neighbor, the glowing wanderer, the pair that dances in Orion. And the whole time, there's been a question building underneath all of it, the one we kept setting aside. How many of these are there, really? In 2023, we finally got a serious answer, and it is staggering. A team led by an astronomer named Takahiro Sumi, working from a 9-year survey that watched the sky for those tiny microlensing flickers, ran the numbers on how often we see rogue planets bend distant starlight. And from how often it happens, you can work backward to how many wanderers must be out there. The conclusion was this: the Milky Way is home to roughly 20 times more rogue planets than stars. 20 times. For every single star in the galaxy, there are something like 20 starless planets drifting in the dark between them. And our galaxy holds hundreds of billions of stars. So we are talking about trillions of rogue worlds. Trillions. Let that resettle everything you've ever pictured about the galaxy. When we imagine the Milky Way, we picture stars, glittering points of light, scattered across the dark, and a handful of planets tucked in close to each one, lit and warm. That's the postcard. That's the image in every textbook. But the postcard is wrong, or at least it's showing you the rare part and hiding the common part. Because the real galaxy, the honest one, is mostly darkness with worlds in it. Trillions of planets, drifting alone, unlit, uncounted, between the stars. The bright solar systems like ours aren't the main event. They're the exception. The lucky few that got to keep a sun. We even have a tool coming that's built to find these things. NASA's Nancy Grace Roman Space Telescope, expected to launch in the next couple of years, should be able to spot something like 400 Earth mass rogue planets all by itself. Earth mass. Worlds the size of our own, wandering in the black. And 400 is just what one telescope expects to catch in its narrow window. A tiny sample of the trillions. As Sumi himself put it, microlensing is the only way we can find objects like these. Low mass, free-floating, giving off no light of their own. For most of human history, they were completely invisible to us. We didn't leave them off the map because they weren't there. We left them off because we couldn't see them. And now that we can, the map is being redrawn, and the new version is almost unrecognizable. So here's where I'll leave you tonight. The next time you look up at a clear sky and see those scattered, lonely stars, try to hold a different picture in your mind. In between every one of those points of light, fill in the dark with worlds. Trillions of them. Planets with iron rain, and water clouds, and auroras, and maybe, on a few of them, oceans under the ice, with something stirring inside. None of them lit. None of them counted. All of them adrift, with no sun to call home. We always thought of ourselves as a planet that belongs to a star. But maybe, in the grand scheme of the galaxy, belonging to a star is the strange thing. Maybe the natural state of a world is to wander, and we are simply the rare ones who, for a little while, got to stand in the light. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. hit that subscribe button so you don't miss them. See you in the next one.